Okay, so okay, we will start our introduction class today. From tomorrow onwards, we'll go into the syllabus. So first, we'll see what is HVAC and go through the basic introduction. So first, before going that, for how the uh, workflow will be there. So where how we'll get the projects and what are the departments involved in this project. So where is when we are going to involve in the project and what are the disciplines involved in this. So we'll see it deeply. So first, whenever we are working in any HVAC industry, so we'll generally get some projects from the clients. Okay, so like that may be buildings, apartments, hospitals, hotels, anything. So that whenever we receive the project, so that we will get it from the clients. So okay, so first that is client. So next one is architect, and so we'll see what is a client first here. So the client is an organization or individual for whom a construction project is undertaken. So the client either he is an individual, so somebody like he is an individual, he wants to construct a like villa or something, so that he will be an individual. So most of the times that will be an organizations, like they want to build a, it's like Microsoft, it's like Google, so they want to build a new office spaces. So they will become the client. Okay, so the who to whom they have taken the project, construction project. So uh, they from for their the organization or individual will become a client. Okay, so the client generally will have like you can see the image. They will have the open area or open plots. So they want to construct something. So we'll get it in the form of open areas generally. Okay, so this is a client. The next one is architect. Okay, so first, whenever they want to construct any building or anything, so first the client will go to the architect. Okay, so they directly don't come to HVAC or MEP engineers. So first they will go to architect. So what architect will do? Architect makes the plan of building according to client's requirement. So it's depending upon the client requirement. So if the Microsoft organization wants to build an office space, so they will take the requirement. Architect will take the requirement of how many floors we need to construct and what are the capacities and what are the types of rooms they required, how many office spaces and like uh, auditorium. So that kind of things, how many they required based on their requirement, architect will make a plan. Okay, so you can see the architect image. So these are done in Revit or some other applications. So this looks like this. So architect finalizes the drawing and he will gives to the client. So like he will make 2 to 3 options. So based on requirement, and they will finalize the architect drawing. Okay. So architect also focused on not only the construction, they will focus mainly on the facade designs also. Okay, so facade nothing but the outside views, whatever we are seeing this in the image. So that kind of views also they will develop in this stage. So okay, after everything was approved by the architect, by the client, and the architect and client has finalized the drawings, so it will goes to the next, that is structural engineer. Okay, so if the drawing was finalized, so next we need to go to the execution stage, and the structural that will goes to structural engineer. So first we'll see what is structural engineer. It will goes to, so he will performs soil testing and lays the foundation, slabs, and pillars. So structural engineer mostly focused on the laying of the foundation, slabs, and pillars. So he don't focus on any other constructions other than the slabs, pillars, and foundations. So and also he will perform the soil test. So what is soil test? Soil test is generally performed to whether in this area the building can withstand these many floors. So if the soil has the capacity to withstand these many floors, the load, so that a test will be performed. And so by doing this test, we also get to know that how much depth we need to lay the foundation to withstand these many floors in this particular area. Okay, so this will they will test this and they will generate the soil test reports. Based on this, they will lay the foundation. Foundation means slabs, pillars. So whatever you are seeing in the image, so they will do the required uh, foundation slabs and pillars, and they will uh, hand over it. So the next process is civil engineer. So after this, the civil engineer will be involved. So what are his roles? We'll see this. Uh, this is a civil engineer. So civil engineer main work is to construct the walls and fix the doors and windows. So after structural engineer has constructed these columns, pillars, and he lays the foundation. So the completing of these, so the civil engineer will take in over this and construct the walls and the fix the doors and windows. So we can see the image. So which has completed with the construction of walls, fixed doors and windows. So this is the civil engineer works. So next, when it is completed, the civil engineer, so the work will be goes to the MEP engineer. So here is our MEP discipline will going to involve. So after completing of the building, so we are going to involve. So in these also we have MEP. So we have four disciplines. So MEP full form is mechanical, electrical, and plumbing. So if you see, we have four disciplines in this. Mechanical, in mechanical we have HVAC. In electrical, yeah, it is electrical, and next one is plumbing, and finally that is firefighting. So uh, these are totally command of MEP. So you can learn total MEP also. So currently we are uh, learning HVAC in this discipline. Okay. So first, what we will see what is MEP. So in MEP we have electrical engineers. So we'll see what electrical engineers will do in this project. So the task of an electrical engineer is to design high voltage equipment such as wiring systems, power distribution systems, generators, and lighting systems. So the electrical engineer, his main role is to give the electricity, distribute the electricity inside the building. So whenever the civil engineer completed the work, so the building will be empty. So there is no requirement, there is no nothing to like there is no electricity, plumbing, firefighting, nothing will be there. So we need to do that. So every building requires some electricity. So the electrical engineers will design the uh, electrical path, like where we have to keep the sockets. So if it is office spaces, for every system they need to give the sockets. And if it is a residential area, also commercial, anything, we need to give some sockets. And if it is a industrial area, so industrial area also, in industries also we need to give the sockets. So in every constructed building, so the electrical engineer he has to work. Okay. So not only the sockets, and he also designed the wiring system from DB boxes to the lighting, power sockets, etc. Okay. So, and lighting also he will be distributed accordingly based on the lux levels. Okay. And also, if you this is a low side work, so if you see the outside work, so if you are distributing the electricity to the entire building, so you need to design the generators also, and UPS. So this all comes under electrical engineers. Okay. So this is the electrical engineer role in the MAP. So next we'll see plumbing. So what plumbing engineer will be do? So plumbing engineer design and prepare drawings for plumbing and water supply system. So we have seen that every, like in our home also everywhere. So we required electricity, so that we have seen. And next thing is plumbing. So plumbing where we will use, like if you see for in every building, so there is a requirement of water. Okay. So water, that may be drinking water or for washing. Okay. So, and for washrooms, hot water, cold water, and we have to drain the water from the washrooms. So, okay, so that comes under plumbing. So, you can see the laid plumbing pipes which has laid in the construction site. So, you can see that PVC pipes. So, this is a major things, like in everywhere we require this plumbing in the buildings. Okay. So next one is firefighting. Firefighting engineers design and provide advice on both new buildings and buildings undergoing refurbishment in respect to fire safety measures. Okay. So their role is to help protect life, property, and the wider environment from risk of fire, and to help ensure the projects meet industry codes and legislative requirements. Okay, so what the firefighting engineers will do, that we'll see. So their major role is to uh, prevent the building from, like getting fires in any case of emergencies. So for example, so if any fire accident happened inside the building, so that may be new construction or old construction. So what will happen? The fire will be continuously occupying the space. Like if it is happened in one floor, one room, so that will we cannot stop at that time. So that will continuously going on. So for it will be occupied in the entire building. So to avoid this, so that because of the fire, the smoke will be generated, and the fire also, so many people can die. Okay, so to avoid this, we will use firefighting designs. So that will be developed by firefighting engineers. So what they will do, uh, they will develop, and they develop the new for the new and old buildings also. Like some old buildings, if they required in that days, they don't use this firefighting. So if they required, so we can give for old buildings also. So what they will do, they will design the firefighting system. So you can see the image. So these are firefighting pipes. Okay, that white color is sprinkler. So whenever the fire happens, so these sprinkler will open, and it will blow. It will throw the air, water inside the room. So due to this, so wherever the fire will happen, so that will automatically opens, and it will throw the air water into the room. So due to this, the fire will be we can decrease the fire inside the rooms. So that is a firefighting engineer. So there not only the sprinkler system, so they will be like uh, diesel pumps, and combination of diesel and other pumps, uh, and also the firefighting safety people, so who are there coming from the outside, so they'll also have the access to uh, send the water into these systems. Okay, so this is the firefighting engineer's role. So this is the most important thing. So it should also protect the like it should be under design under the industry codes, so like NFPA, National Fire Protection Act, and legislative requirements. So like government rules and regulations we need to follow, and also the industry codes like NFPA, IBC, so that we need to follow while we are designing firefighting. Okay, so these are the basic MEP introduction. So we'll go to our HVAC topic. So we'll see our HVAC introduction. So mechanical engineer. So in MEP we call HVAC as a mechanical term. So an HVAC engineer is responsible for taking care of all heating, ventilation, and air conditioning needs. Okay. So what is our role, major role in designing any building, designing of the HVAC for any building? So that is of like he first one is heating, the next one is ventilation and air conditioning. So what is heating? So if you see, um, the temperatures may change from weather to weather. Okay, so in summer the temperatures is high and the winter the temperatures will be low. So if we want to operate, if we are giving any HVAC design, so the heating should be also accumulated inside the air conditioning system. So heating we required in the winter season. If you see in India, so in other countries, so there will be like this will minus degree temperature. So there in the winter season. So there there we need to give the heating properly, so then we can like in minus degrees temperature also the certain human comfort temperatures we can maintain. So that is heating. And air conditioning. So air conditioning, we know that present days now everyone is going to use this air conditioning system. So that is just for a comfort application. So like if your the temperatures are high, like 35, 40, so our human comfort feeling temperature that is 24 degrees centigrade. So by using the air conditioning equipment, we will maintain the temperature of 25 degrees centigrade. So that is for the comfort. And ventilation system. So what is ventilation system? Ventilation system generally used for extracting the air, contaminated air, and throwing outside and taking the fresh air from the atmosphere and sending inside the room. So you can see extraction of exhaust air from inside to outside, from fresh air from outside to inside. So where we will use this ventilation system? First application is toilets. So toilets generally we the air is of contaminated with the smell, everything. So there we need to exhaust that air and we need to send some fresh air. Okay. So another one application is kitchen. So kitchen ventilation also, that there will be like continuous cooking inside the kitchen. So due to this, the air is fully mixed up with the smoke of cooking and also the oily masalas, everything and all. So there also we need to extract the air and we need to send some fresh air. So other than this, we have staircase pressurization. Staircase pressurization, nothing but like in basements. So if you go for underground basement, so there is no ventilation available there. So we need to give like cars will emit some carbon monoxide. So that is not good for the people inside the basement. So based on that, we will extract the air and we will send some fresh air. So that is also comes under ventilation system. And next one is uh, kitchen ventilation. We have seen toilet, staircase, okay, and staircase pressurization. So staircase pressurization, it won't comes under there is no any exhaust systems, but staircase pressurization is required. So in case of any fire accident happened inside the building, so the people will use the staircase as a exit. So they will come to staircase and they will try to exit from the building. So there, if they open the doors, the what will happen? The smoke, which is generated inside the building, will come inside the staircase area. So there they cannot see the staircase. So that will the smoke will be occupied in the staircase. So to avoid this, we will give a pressurization unit. So we'll pressurize the staircase with the some air. So what will happen whenever they open the door and they are going to exit, so that this pressurized air will throw the air inside the room. So due to this, the smoke will not enter inside the staircase. So that we are going, we'll see it in our upcoming classes deeply. So this comes under ventilation systems. Okay. So heating, designing for the cold climate, and air conditioning, designing the system for hot, dry, or humid climate. Okay. So these are the exhaust systems you can see. Just now we discussed exhaust system, kitchen exhaust, car parking ventilation, and toilet exhaust system. So next one is fresh air. Fresh air in air conditioning system to improve indoor air quality. So what is fresh air? Fresh air means like if you installed a AC inside your room. So if you when you install that, what you will do, you will close everything like windows, doors, everything. You close it for maintaining good temperature. So what will happen? People inside that room uh, will not feel comfortable due to there is no fresh air. So the air is recirculated there itself. So it is not good for human health. So if there is no fresh, so what we'll do? We'll generally take some fresh air from the outside, that we'll know how much fresh air we need to take for each room, each and every room in the designing part. So that amount of air we will take it from the outside atmosphere and will connect to our unit. So what will happen? By this, the certain 10% or air or that air will be continuously taken from the atmosphere, so that the indoor air quality will be maintained, and for humans also feel comfort, and that is good for the health. Okay. So we have ASHRAE requirements for the fresh air. So when we going into heat load calculation, so we will see what are the fresh air requirement inside the every application. So we have some codes and standards of HVAC. So whenever we are going into designing part, we need to go to the follow the certain codes and standards. So we cannot design as we required. So whenever we are designing the HVAC system, so these are the some major codes and standards of HVAC that we need to follow. Okay, so this we have the data books. So the heat load, we generally use ASHRAE or ISHRAE database, and duct designing we'll use MACNA. So like this, we have different types of codes and standards. So first we'll see ANSI, American National Standard Institute, and next one is ISO, the International Organization for Standards, and next one is ISHRAE, Indian Society of Heating, Refrigeration, and Air Conditioning. So this is the major thing. So ISO and ANSI are very rarely used codes and standards, but these are used on regularly basis in ISRAE. So that ISRAE was developed for the Indian people. So if the projects were you were working in India, so you can go through the ISRAE handbook. So in ISRAE handbook, you will have everything like what are the weather data, outside weather data, inside weather data requirements, and the duct designing, pipe designing, everything will is there in the ISRAE handbook. So next one is air conditioning and refrigeration unit. So this is something like a uh, the research institute. So that will be useful for the equipment manufacturers. And next one is ASHRAE. This is the most important thing. American Society of Heating, Refrigeration, and Air Conditioning Engineers. So the ASHRAE is the major thing. Like when these all ISHRAE and everything was developed by using the ASHRAE. So ASHRAE we have handbooks. So ISHRAE also work under the codes and standards that was developed by using ASHRAE only. So in ASHRAE handbook also we'll get worldwide uh, data. So that is of outside data temperatures. So in every season, what is the outside temperatures, what is the inside temperature? So that we'll get in an ASHRAE. So ISHRAE that is only particularly for the Indian conditions. So next one is ASME, American Society of Mechanical Engineers, and ASTM, American Society for Testing and Materials, AWS, American Building Society, and National Fire NFPA, National Fire Protection Association. So this is also used. This generally used for the firefighting engineers, NFPA. And next one is Magna, most important, Sheet Metal and Air Conditioning Contractors National Association. STA, Steel Tank Institute. Okay. So in these, the major codes was ISHRAE, ASHRAE, and NFPA, that is for firefighting, you can see, and SMACNA. So these are the major codes we need to remember every time. So these are the full forms, so that may be asked in any interview. So just you need to by heart this full forms. Okay. So these are codes and standards. And introduction. So what is air conditioning system? We will see. So the term air conditioning system has gradually changed from just cooling to the total control of. So in previous slides we have discussed that air conditioning is used for the maintaining the temperature. So that it has changed from cooling to the control of other applications also. So other terms also. So what we'll see the what are the other terms required. So first one is temperature. So the temperature everywhere we need to maintain, that is of human temperature comfort 24 degrees centigrade. So 24 degrees centigrade is the human level of comfort temperature. Next one is moisture in the air, humidity, and human comfort 50 to 60%. So not only the temperature in the air, so we need to control the moisture also. So for example, when you uh, when the temperature is in cool condition also, we don't feel comfort. So that is due to the moisture. So in ocean areas, seaside areas, so the high humidity will be high. So due to this, so if the temperature is low, then also they will not feel comfort. So that is because of the humidity. So this we are going to discuss in our next classes deeply. So here the human comfort humidity is 50 to 60%. So remember this first and second point. Human comfort temperature is 24 and human comfort humidity is 50 to 60%. So these terms you need to remember that we are going to use it in the upcoming calculations. So next one is supply of outside air for ventilation. So we have discussed that for kitchen ventilation, like toilet exhaust. So there we required some outside air for ventilation and also the fresh air for the human comfort. Okay. And next, filtration of airborne particles. So filtration also most important. So for example, when you are taking some fresh air from the outside, so you cannot directly take the air. So you need to filter it first. So filtration is most important because the outside air will be of contaminated like with the dust, particles, and insects, everything. So you cannot take directly and throw it into the room. So you need to filter so that particles, everything will be get filtered and fresh air will be sent inside the room. And fifth one is air movement in the occupied space. Okay. So guys, if the call will get disconnected. Okay, if the call will get disconnected, so in Zoom we have 40 minutes free time. So if the call will get disconnected, please rejoin. So we'll continue. Okay. So we have only 4 minutes left. Okay. For every class from today onwards, if the call is gets disconnected, so you can join again. Okay. So here the fifth one is air movement in the occupied space. So we have seen temperature, moisture, and ventilation filtration. So other major term is air movement in the occupied space. So that is comes under like if you have taken some big room. So you have placed an air conditioning equipment on one end of the room. So you have hanged one end on the corner. So what will happen? The air will not move inside the room, and the one end people will get more air and more temperature. One end people will get a very less temperature. So, and also when you place the AC, so you need to see that whether there is any object which is like stopping the air to go in the free direction. So if there is any kind of equipment, anything is there, so you need to you no need to place the AC there. So you need to place where there is no obstacles.